Hello everyone, my name is Sarosh. I am a student of BCIBM at Gopal Narayan Singh University. Let me introduce my faculty, Mr. Arup Kadia, Assistant Professor of FIT GNSU. Let's overview on my first point. Mastering Object-Oriented Design. Embark on a journey to understand and implement object-oriented design principles, enabling to craft software that is not only functional but also maintainable, scalable, and adaptable to future changes. Let's move on to the next slide. The why of OOD, tackling complexity with elegance. In the intricate world of software development, complexity is an internet challenge. Object oriented design offers an elegant framework to manage this complexity, breaking down large systems into modular, understandable components. Manage complexity. Simplify complex systems by breaking them into smaller, manageable parts. Second, enhance modularity, creating independent, reusable modules that are easier to develop and test. Third, promotes scalability, designing systems that can easily grow and adapt to new requirements without extensive rework. Fourth, improves maintainability, making code easier to understand, debug, and modify over its life cycle. Let's move on to the next slide. Core principles: encapsulation, inheritance, polymorphism, abstractions. At the heart of OOD, four fundamental principles that guide the creation of well structured and flexible software. Understanding and applying EIPA is crucial for effective object oriented programming. Encapsulation, building data and methods that operate on the data within a single unit, hiding internal state from external access. Second, inheritance, allowing new classes to inherit properties and behaviors from existing classes, promoting code reuse. Third, polymorphism, enabling objects of different classes to be treated as objects of a common type, allowing for flexible and extensible code. Fourth, abstractions, focusing on essential features while hiding unnecessary details, simplifying interactions with complex systems. Move on to the next slide. Solid principles, a foundation of maintainable code. The solid principles are a set of 5 design principles intended to make software design more understandable, flexible, and maintainable. As these principles leads to robust and adaptable codebase. First, single responsibility principles. A class should have only one reason to change, meaning it should have only one job. Second, open closed principles. Software entities, class modules, functions should be open for extensions but closed for modifications. Liskov substitutions principle. Objects of a superclass should be repeatable with objects of its subclasses without breaking the application. Fourth, interface segregation principles. Clients should not be forced to depend on interfaces they do not use. Many client specific interfaces are better than one general purpose interface. Fifth, dependency inversion principles. High level modules should not depend on low level modules. Both should depend on abstractions. Abstractions should not be depend on details. Details should not depend on abstractions. Move to the next slide. Design patterns, reusable solutions for common problems. Design patterns are generalized reusable solutions to commonly occurring problems while a given context in software design. They are not direct solutions but rather templates that can be adapted to specific situations. Creation patterns, singulation, factory method, builder. Focus on object creation mechanism, striving to create objects in a manner suitable for the situation. Second, structural patterns, adapter, decoder, facade, concerned with how classes and objects are composed to form larger structures. Third, behavior patterns, observer, strategy, command, deal with the communication and interactions between objects and how they distribute responsibilities. Let's move on to the next slide. Practical application, modeling a real world scenario. Let's consider a practical exam to illustrate how OOD principles are applied Imagine designing a system for a library. We can identify key entities and their relationships. First, member, borrowing, librarian, library catalog, book. This model demonstrates how real-world entities are translated into objects, encapsulating their data and behaviors and how they interact without these systems. Let's move on to the next slide. Code walkthrough OOD in action with a simple example, a hands-off demonstration of how OODD principles translate into actual code. We will explore a simple example, perhaps a shape hierarchy to show inheritance and polymorphism. Here are some code. This is example highlights how different shapes can be treated as a generic shape, showcasing polymorphism and inheritance in a clear manner. Let's move on to the next slide. Beyond the basic, advanced concepts and best practices. Once you have a solid grasp of core and solid principles, you can delve into more advanced OODD concepts and best practices that further refine your software design skills. First, refactoring, restructuring existing computer code without changing its external behavior. Second, code smells, identifying indicators of deeper problems in the code that might lead to design flaws. Third, architectural patterns, exploring patterns like MVC, MVP, MVVM for structuring an entire application. Fourth, testing strategies, implementing unit integration and end-to-end test to ensure code quality and robustness. These advanced topics ensure your OODD journey continues, leading to even more sophisticated and resilient software solutions. Let's move on to the next slide. Key takeaways and next steps. Your OODD journey begins. Object-oriented design is a powerful paradigm that empowers developers to build better software. Embrace these principles and continue to learn and apply them in your projects. First, embrace EIPA. Master encapsulation, inheritance, polymorphism, and abstractions. Second, apply solid, build maintainable, and scalable code with solid principles. Third, continuous learning, explore advanced concepts and best practices. Fourth, utilize patterns, leverage design patterns for proven solutions. Start applying OODD in your next project, reviewing existing code through an OODD lens, and engage with the OODD community, deepen your understanding. Thank you.